Hey, Linford here, and today we're going to be talking about how to solve a system of equations in 3 variables. In particular, we're going to talk about what solutions for this might look like, and we're going to go over the process for how to do this. So, solution types. Previously, when we had a system of equations in 2 variables, we were solving for an ordered pair. We were solving for x and y. And that's what we wanted to find. We wanted to find the x and y, the specific ordered pair that worked for both of the 2 equations. Now what we're going to do for a system of 3 variables, I'm throwing in an extra variable, we're going to find, instead of an ordered pair, I want to find an x, a y, and a z. I'm going to find an ordered triple. An ordered triple is basically what values for x, y, and z can I plug into all of the equations to make them work. It's the same idea as before, but we've just tacked on an extra variable. Now, let's start by going over what's the process for how to solve this by actually solving one of these 3 variable systems. You'll see right here I have 3 equations that all have an x, that all have a y, and that all have a z. What we're trying to do here is trying to find what values for x, y, and z satisfy all of the equations. What should I plug into each of these equations to make them all true? This is a very elaborate process, so go ahead, work with me on this, follow along, make sure you take notes, and pause the video if you have any questions, okay? First thing that I want us to do is let's label these equations A, B, and C. I think it's easier to label equations right from the beginning so that way we can reference them as we go along. So for part 1, what I have to do first, I have to do, pick 2 equations and cancel out 1 variable. All right, let's pick 2 equations and we're going to cancel out a variable. It does not matter which 2 equations I pick or what variable I pick to cancel out. I'm looking at this, I don't know, maybe A and B. I'll pick the equation A, which is 2x plus y minus 3z equals -7, and I'll pick the equation B, 3x minus 2y plus z equals 11. Again, it doesn't matter which 2 equations I pick, does not matter. I just picked these ones, and I decided, you know what, I'm going to cancel out the z's. Again, it does not matter what variable I cancel out. I could cancel out x, I could cancel out y, but I'm looking at this, I don't know, maybe I'll cancel out the z's. So what do I have to do to cancel out z? Well, I'm going to leave equation A as it is, but I'm going to multiply equation B by the number 3. So I get 9x minus 6y plus 3z equals 33. I'm using the elimination method. I'm canceling out the 3z's, and I get 11x minus 5y equals, let's see, 33 minus 7 should be 26. And there we go. That's my new equation. We'll call this equation E, okay? So I've canceled out one of the variables, and I got this new equation, 11x minus 5y equals 26. Okay, stay with me. What we're going to do now is we're going to repeat this process. We're going to repeat the process, but we're going to do it a little differently. And hopefully, after the next step, you'll see why we're doing this. So, let's jump over to part 2. For part 2, I want to pick 2 new equations and cancel out the same variable. Pick two new equations, and we're going to cancel out the same variable as before. All right, so let's take a look at this. Before we picked A and B, I now need to pick either B and C or A and C. I can no longer work with A and B. Instead, I have to pick two new equations. And in these two new equations I pick, I'm going to have to cancel out the variable z. So we start with a lot of freedom. Pick two equations and pick a variable to cancel out. The second part says, okay, pick two new equations. Don't pick the ones you already used, but you have to cancel out the same variable. All right, well, I already used A and B, so why don't I use B and C? That seems like it should be fairly easy. So I'm going to use equation B, which is 3x minus 2y plus z equals 11. And I'm going to use C, which is negative 2x, darn stylus, negative 2x minus 3y minus 2z equals 3. Okay, we have to cancel out the z variable, so I'm going to multiply this equation by 2. We're going to end up with 6x minus 4y plus 2z equals 22. Negative, on the bottom I have negative 2x minus 3y minus 2z equals 3. Let's add these together. The two z's are going to cancel out, and we're left with 4x minus 7y equaling 25. Okay, this is going to be our equation D. So, our previous work, we got equation E, and in this work, we end up with equation D. What do you think is going on here? Why am I doing this to where I combine all these to get an equation E, and I combine all of these to get an equation for D? What do I do when I have these two equations that I produced? I'll write them down again here. Equation E is 11x minus 5y equaling 26. And equation D is 4x minus 7y equaling 25. What do you think we should do here? What's going on? Well, hopefully you're realizing we just took a system of equations in 3 variables and we broke it down into a system of equations in 2 variables. Solve the system of equations D and E. That's all we're doing here. We're solving these 2 equations. Okay, so let's solve this system. Let's pick one of these variables to cancel out. I don't know, let's cancel out y. I don't know, let's just pick one. So I'm going to multiply the top and the bottom. So if I want to cancel out y, I'm thinking what should their coefficients be? I'm thinking that the number 35. Maybe if the top became positive 35, so I multiply it by negative 7. And if the bottom became negative 35, so I multiply it by 5. I don't know, maybe that'll work. So let's see. We have negative 77x plus 35y equals, let's see, 26 times negative 7 is going to be negative 182. And then if I distribute the 5, I get 20x minus 35y equals, that should be 125? Yes. Adding these together, my y's cancel out, and I'm left with negative 77 plus 20 should give me negative 57. X equals, let's see, 182 minus 125 should be 57. So if we go ahead and divide by negative 57 on both sides, we have x equals, well, what's negative 57 divided by negative 57? That should be positive 1. So there we go. X equals 1. Now hold on a second. We just did all of this work to say x equals 1. But don't forget, we need to find not just x, but we also have to find y and z. So we started by taking all this work in the blue, working with these two larger equations to get a system of two variable smaller equations, okay? Then we solve that two variable system to find x equals 1. So what we now have to do is we have to figure out what y and z are. Well, it's actually pretty easy going from here. All we have to do is plug in the variable to solve for the other in equation D or E. So what that means is, hey, do what you just did before when you had a two-variable system. You know what x is. Plug it into one of these to figure out what y is. I don't know. I mean, I guess it really doesn't matter which I plug into, but I don't know. I guess I'll just plug into D. So D, equation D said 4x minus 7y equals 25. And I know that x equals 1, so I'm going to plug in 4 times 1 minus 7y equals 25. So 4 minus 7y equals 25. Subtract 4 from both sides. Negative 7y equals 21. Divide by negative 7. And we get y equals negative 3. And that's it. There we go. We have what y equals. Okay, now that we have what y equals, let's go ahead and figure out what z equals. Now you might say, well, how the heck do we go about and do that? Well, it's actually just the same idea as before. All we need to do is plug in the variables to equation A, B, or C. So I know what x and y equal. I know what they are. So to figure out what z is, plug it in to one of these. Plug in x and y into one of these original equations and figure out what z is. Simple as that. So okay, let's go ahead and do that. So, oh gosh, I don't know. I'm going to just pick, again, it doesn't matter, but I'm going to pick equation B. That seemed like an easy one. So equation B was 3x minus 2y plus z equals 11. All right, I know that x equals 1 and y equals, oh gosh, what did y equal? Y equals negative 3. Okay, these are the two I've already solved for, so let's plug them in. 3 times 1 minus 2 times negative 3 plus z equals 11. So that's 3 plus 6 plus z equals 11. So that's 9. That's a terrible 9. That's 9 plus z equals 11. Z equals, well, 11 minus 9 is going to be 2. So now I have z equals 2. So I've gone and solved this entire system. I found all three of the variables that are solutions for this. So let's write it down as an ordered triple. My solution is going to be 1 for x, negative 3 for y, and 2 for z. We have gone through and we've just solved a system of equations in 3 variables. This is how it's done. It's as simple as that. It's kind of an elaborate process. Of course, it's very elaborate. However, it's not that bad once you start getting in the hang of it and you just keep practicing these steps, okay? It's not as bad as you think it would be, okay? So let's try another one. Let's try one more. So we first should label these A, B, and C. Step 1, let's pick two of these equations and cancel out a variable. I don't know, let's take equation A, which is 2x plus 3y minus 7y equaling 4. And let's take equation B, which is negative 4x minus 6y plus 14z equals 1. Again, it doesn't matter which two equations you pick, just pick two and cancel out a variable. I don't know, maybe I'll cancel out the x's. So I'm going to multiply this by 2. Again, it doesn't matter what I cancel out, just pick something, okay? Oops. So I multiplied everything by 2 here, and then here I just leave it the same. Oh, that shouldn't be a y, that should be a z, my bad. And this should equal 1. Okay, let's go ahead and add these together, and my x's cancel out, and oh, look, my y's and my z's also cancel out. And I'm left with 0 equals 9. Well, that's not true, that's a contradiction. So what's going on here? Well, we can actually go ahead and say that this is inconsistent. No solution. This is an inconsistent system. It has no solution to it because right away, as I'm trying to solve this problem, I immediately came across a contradiction right away. If you are doing work to solve a system of equations in 3 variables, and anytime you come across a contradiction, you automatically say, I have to stop my work. I have to stop here. I can't go any further. And you say this is inconsistent and it has no solution to it. If you were to come across a problem and say you got 0 equals 0 or 1 equals 1, whatever, and you came across an identity, you also have to stop your work, except in that case you would say you have infinitely many solutions. So anytime you come across an identity or a contradiction, you have to stop your work. You can't go any further. If it's a contradiction like right here, you say no solution. It's inconsistent. If you get an identity, for example, you would stop your work and say infinitely many solutions. I can't go any further. I automatically have an identity or contradiction here. So these are actually fairly easy to solve because you don't have to do much work when solving these. You know, you do a couple steps and then you're immediately going to hit a contradiction or an identity. All right, well, hopefully this is making sense to you. Again, if you have any questions or comments, feel free to send me an email. My email is klinford@wccnet.edu. Let me know what you think of the video. If you have any questions, comments, or concerns, feel free to send me an email about that. Until next time, take care.